So last class we discussed about this quantity called momentum, which effectively gives us a measure of inertia of motion. Means it tells us how hard it is to disturb the state of motion of a particular system. Okay, and this state of motion, when we say it, it is understood that the system is already moving. Okay, so how hard it is to disturb that kind of a system is what is given by momentum. And how is it calculated? P is equal to mv. If a mass m moves with a velocity v, then its momentum p is equal to mv. Okay, and we discuss units and all. In case there are different parts of the system moving with different velocities, then the total momentum of the system is calculated like this. You have to calculate individual momentum of each part separately and add them up. And momentum being a vector quantity, you have to add it as vectors to get the total momentum of the system. Then we solved some problems based on total momentum, change in momentum. And then we talked about this other quantity called impulse. Impulse by definition is a sudden change in momentum. So it's basically delta p, p final minus p initial, but it should happen suddenly. It should cause an abrupt change in the motion of a system. Then we call it impulse. Otherwise, we simply call it change in momentum. That's the only difference. And we solved some problems based on that. Then we discuss Newton's first law, which is the law of inertia, which basically states that an object's state of rest or motion can be disturbed only if a net non-zero force acts on it. Okay, the state of rest or motion will be disturbed if a net non-zero force acts on it. And reverse. If a net non-zero force acts on a system, its state of rest or motion should get disturbed. Compulsory. Okay. We discussed some examples of that. Then we moved on to second law. Now we know that force causes a change in state of rest or motion of the system. So basically force changes the momentum of a system. Okay. So second law relates force to momentum, and basically the law states that the rate of change of momentum of a system with respect to time is proportional to the net force acting on the system. So Fnet proportional to dp by dt, F naught is equal to dp by dt. If mass of a system is constant, okay, see, there are cases where mass of a system could change, like additional mass could get added as the system is moving, or mass could leak out of a system as it is moving. We'll come to those cases later. But if mass of the system does not change, then Newton's second law can be written this way: F net is equal to ma. Okay, where m is the mass of the system, fixed mass, a is the acceleration. Okay, but remember this term, this is crucial. Net force is mass into acceleration. Okay, net force is the resultant of all forces acting on the system. Fine. Let's solve some problems based on this first. So this class and maybe the next few classes will be discussing applications of Newton's second law. Applied to a system of constant mass. Okay. Suppose there's an object on which multiple forces are acting. Let's say mass of the object is some 2 kg. Assume there's one force acting on it this way, 10 Newton. Another force acting on it this way, 10 Newton. Okay. So there are two forces and you know the mass of the object. Derive acceleration of the object. Clearly the formula to be used is F net is equal to ma. So you get from this formula itself, you get acceleration of the system is the net force acting on it divided by the mass. Mass is clearly given to you. Fnet is not directly given. You have to calculate that first so that you can find out the acceleration. For convenience, you can call the forces as F1 and F2. Solve it quickly, all of you. I'll give you 2 minutes. Any answer, anyone?
5
Okay.
I cap plus 5 J caps.
5 I cap plus 5 j cap. Correct. Correct. See, if you need to calculate the acceleration of an object in any case, you first need to find out the net force acting on it. Now, there are two forces. Each force's magnitude is 10 Newton. So, Pawan, you tell me, how do you add forces? Like two forces magnitudes are 10 and 10. Will the resultant be 20?
No, sir.
Why?
Sir, we should change them into I cap and J cap.
Good. Forces are vector quantities, right? To derive the net force, you'll need to treat them as vectors first. So, can you express the first force F1 as a vector?
10 I cap, sir. Plus 10 I cap.
It's 10 units in the positive x direction. Next force as a vector,
Plus 10 J cap.
10 j cap. Combine them. How much is the net force then? Add them, that's all.
10 I
10
cap.
I cap plus 10 j cap. That's the net force and divided by mass. Mass is a scalar quantity. Mass is 2 kg in this case. So acceleration becomes 10 I cap plus 10 j cap divided by 2. The unit will be meter per second square. Makes sense. One of you quickly tell me what is the magnitude of this acceleration.
5 root 2.
Root of 5 square plus 5 square becomes 5 root 2 meters per second square. Correct. Okay, let's try another question. Saket, this is clear. Any doubt in this? Okay. Next question. Imagine there is a block. Block mass, let it be some 5 kg. Forces acting on it, one this way. One force. Okay. Derive the magnitude of acceleration of the block. Solve this quickly. Okay, any answer?
10 meter per second, sir.
Second square. Okay, we'll see. Pawan, any answer? Saket?
2 meter per second square.
2 meter per second square. So 10 by 2 చేసిన 10 by 5 చేసిన. Okay. Saket, any answer? Okay.
Okay.
Fine. Let's name these forces as F1, F2, and F3. Saket, can you express F1 as a vector?
Plus 10 I cap, sir.
Okay, correct. F2?
Minus 4 J cap.
Correct. F3?
That's where I couldn't do it, sir.
You just have to take components. No, you know the magnitude of the vector. You know what angle it makes. Angle with x-axis is 37 degrees. So how much will its x component be? How do you calculate components?
A cos theta.
That's all. So it becomes 20 cos 37. Cos 37 is 4 by 5, 16 units. Okay, 16 units to the left. So effectively it is minus 16 I cap. Saket, tell me the y component yourself.
Uh, 12, sir. Plus 12 J cap.
Good. So express the vector F3 as express the force F3 as a vector now. Add the components. Okay, it will be minus 16 I cap plus 12 J cap. All three in newtons. So add them. The net force on this block then becomes I caps 10 I cap minus 16 I cap. So minus 6 I cap. And J caps 12 minus 4 plus 8 J cap. Minus 6 plus 8 effectively is like minus 6 and plus 8. The net force on this system is in this direction. On this block is in not exactly along the 20 Newton vector, but it's somewhat like this. Minus 6 I cap plus 8 J cap. Okay. That's all. From that you can get its acceleration. Let's divide the net force by mass. And see, you were asked to calculate only the magnitude of acceleration, not along with the direction. You can do that this way. Get the magnitude of net force and divide it by mass. Net force being minus 6 I cap plus 8 J cap, magnitude becomes 10 newtons. Divide by the mass of 5 kg. The answer is 2 meters per second square. Okay. Vanilla, maybe you didn't do that division. Fine. Okay, now answer this directly, anyone. If the net force on a system is 0, how much will its acceleration be? If the net force on a block or a mass is 0, how much is its acceleration going to be?
0, sir.
0. Okay. Acceleration is simply net force divided by mass. And if this is 0, the acceleration also becomes 0. Correct. Okay. So this is one direct application of Newton's second law. If you know the forces acting on the object, you can tell its acceleration. Okay. But there could be multiple forces. There can be connected objects. See, things can get very complicated. We'll discuss such situations also. Okay. But before that, let's talk about Newton's third law. Interesting law and many times misunderstood also. Can one of you tell me the statement of Newton's third law? I'm sure you must have heard of it in your lower classes also.
Every reaction has an equivalent and opposite reaction.
Repeat.
Sorry, bro. Force పెట్టడం అంటే అంతే force return backward.
Correct. Tell the statement.
Every force has an equivalent and opposite reaction.
Okay. They say every action has an equal and opposite. Equal means equal in magnitude. Opposite means opposite in direction. Okay. Reaction. Yeah, but yeah, I appreciate what you said. You said every force has an equal and opposite reaction. That is correct. Okay. In Newton's third law, when we say every action has an equal and opposite reaction, action is a force. Reaction is also a force itself. Newton's third law talks about forces. Okay. Not some other kind of action and reaction. Fine. Can one of you give me an example where we observe this? Have any of you ever, or can you think of any situation where this is observed?
Sir, an accident.
What happens during an accident? How do you say Newton's third law is seen there?
Sir, for example, a car hits a wall, let's just say, then the amount of force the car is exerting on the wall, the wall exerts an equal amount of force on the car. So the car gets compressed.
Correct. Okay. So an object going and dashing into another object. If A dashes into B, A will exert a force on B, B will also exert a force on A. Okay. Because, yeah, he has given the example of a car dashing into a wall. We know the wall experiences the force because you'll see some scratches and damage on the wall. And the car also experiences some force. How do we see that? We see the car getting damaged because that means there was some force on the car as well. Correct. Pawan, can you tell me an example? Venala, you also. You don't see this happening anywhere around you. Okay, fine, fine. See, whenever an object exerts a force on another object, there will definitely be a reaction to that. Okay. And remember, there are some important points to note here. We said every action has an equal and opposite reaction. That's true. Magnitude of the reaction will be same as magnitude of the action. Direction will be exactly opposite. Some other things you need to note are, see, action, as I said, is a force. Now, force is exerted by one object on another object or by one particle on another particle. Okay. So if A exerts the action force on B, then B exerts the reaction force on A. Okay. Action and reaction don't act on the same object. And also, if A exerts action on B, B won't exert the reaction on someone else. B will exert reaction on A itself. Okay. And those two forces become something we call as an action reaction pair. Let's take an example. Let's think of an example to this. Let's say there is a table with a block placed on it. Just a moment. Never mind. Okay. Tell me, suppose there's a table with a block placed on it like this. One of you tell me what forces act on the block. The system is observed to be at rest. Okay, table plus block, everything is observed to be at rest. What forces act on the block?
Gravitational force.
Gravitational force, that is its weight, correct? Weight acts downward, so let us indicate the force like this. Now listen, weight of the block is one of the forces acting on it. Okay, and as we just discussed, according to Newton's third law, not just according to Newton, it is observed in nature that for every action there's an equal and opposite reaction. For every force there is an equal and opposite force, reaction force. Now weight is a force acting on the block. One of you tell me what is the reaction to this force?
Normal force.
Action force is weight of the box or block, whatever it is. I'm asking you what is the reaction to it. Pawan, what are you saying?
Sir, normal force.
Normal force on the block. Okay. Let us discuss. Venla, what is your answer? What is the reaction to this? If you can't think of
Normal
any
force,
answer.
sir.
Okay, you're also saying normal. Okay. Saket, any thoughts on this?
Sir, normal only. Is it?
Okay, fine. Which object exerts normal force on the block? What exerts normal force on the block?
Table, sir.
Table. Okay. Now, suppose the table was not there. Will the block still experience weight or not?
Yes, sir.
Yes. And weight is a force. Okay. Does that mean now there is no reaction to it? In this case, you tell me, suppose a block is released in air. You know its weight will be acting on it, due to which it will start falling down also. Where is the reaction to that force if the table is not there? Any answer? Okay.
So
So
the object itself has a normal force acting on and gravitational force is acting on it.
no. Can you repeat? If there is no table and you release a block, my question was, what is the reaction to this force called weight? What did you say?
So I said that when the object is free falling, let's just say, then number one, it will be air resistance. Sir.
No, suppose
The
air is
second one
also
would
not
be
there.
that
Let's say it's a
if it,
vacuum chamber.
okay, sir, if it is a vacuum, then the object is exerting normal force by itself in the opposite direction of gravitational force.
How can object exert force on itself? See, if an object can exert force on itself, that means you are saying objects can accelerate all by themselves. That does not happen, no, in nature. Okay, if an object has to accelerate, it needs help from surrounding agents, surrounding objects. It needs force from something else. Only then an object can accelerate. Or do you think otherwise? Do you think objects can accelerate by themselves? I'm asking all of you. Can an object accelerate on its own without help from surroundings?
No, sir.
No, sir.
Saket, what do you say? Can you think of any case where an object accelerates by itself?
No, sir.
It's simply
No,
not
sir.
possible. Okay, it's simply not possible. Even if you take the case of a rocket, now see, rockets are in outer space, so gravity won't be there. Okay, imagine a rocket in outer space, far from the Earth, no gravity, and outer space is vacuum. So basically, there is not much influence from the surroundings on the rocket. But rockets do accelerate. How? Okay, we'll discuss that in this chapter itself. See, the rocket is actually a combination of small systems. Like the body of the rocket is one system, the fuel in the rocket is another system. You have to take it like that. So body of the rocket goes one way, fuel goes the other way. So it's like fuel helps the body of the rocket to move. If you take body plus fuel, effectively the system is not moving. You learn this in when we discuss the concept of conservation of linear momentum. But for now, you understand or remember that no system can accelerate without help from the surroundings. Okay. Yeah. Now let's come back to this question. My question was, what is the reaction to the weight of this block? And Saket, your answer is not correct. Pawan and Vanilla, can you think of any answers? Now there is no table, so there's no normal reaction. But every force should have equal and opposite reaction. Then what is the reaction to this?
I have a doubt, sir.
Yeah, go ahead.
సార్ మీరు ఏ ఆబ్జెక్ట్ దాని అంతటా యాక్సలరేట్ అవ్వదు అన్నారు కదా సార్,
Ah,
కానీ కార్ యాక్సలరేట్ అవుతుంది కదా సార్.
ఇప్పుడు కారు చెప్పు, స్లిప్పరీ రోడ్డు మీద కార్ యాక్సిలరేట్ అవుతుందా? అంటే కొద్దిగా అవుతుంది సరే, బట్ డస్ ఇట్ యాక్సిలరేట్ యాజ్ మచ్ యాజ్ ఆన్ లైక్ రఫ్ రోడ్?
నో
That means the road has a role to play. If there is no road, if you suspend a car in air, okay, you press on the accelerator howsoever hard you want, the car is not going to accelerate. Venla, what do you think about that? Do you
Sir,
agree with that statement or not? Just a moment. We'll finish the discussion. A car like this, suppose it is suspended using a crane or something. Let's say it is tied up. How much ever you press on the pedal of the car, it's not going to accelerate. Okay. Venla, is it correct or not? What I'm saying is correct or not?
ఎస్ సార్.
Yeah, Saket, you were saying something?
సార్ ఇప్పుడు నార్మల్ గా వాక్యూమ్ లో ఆస్ట్రోనాట్స్ ఉన్నప్పుడు మూవీస్ లో కూడా చూస్తాం కదా, స్లోగా మూవ్ అవుతారు వాళ్ళు. సో వాళ్ళు
See,
ఎక్కడ యాక్సలరేట్ అవ్వకుండానే యాక్సలరేట్ అవుతారు.
no. There they push against the wall of the spaceship or something like that. Okay, you learn those in the concept of conservation of linear momentum. It's like the walls of the spaceship and all help them. They push against one wall, they move the other way. They push against this wall, they move this way. Yes or no? It is kind of like that.
అంటే సార్ స్పేస్ లో కాదు సార్,
when they're out of the spaceship.
లైక్ మొత్తం నార్మల్ స్పేస్ లో. ఎస్ సార్, స్పేస్ వాక్ చేస్తున్నప్పుడేమో అలాంటి
See, from where do they go into space? How do they get there?
స్పేస్ షిప్స్.
So when they are exiting the spaceship, they will push against it. Or there is another possibility also. They may have jackets which can, which have what do you call, propulsion nozzles, like a rocket itself. How does a rocket move? Just a moment. Basically, what it does is, it like Diwali rocket itself. You consider, how does a Diwali rocket go up? Sound is chepadu. What is the mechanics behind it? How does a Diwali rocket propel itself, move? Okay, have any of you ever heard of recoil of a gun? Recoil of a gun.
సార్.
What does recoil of a gun mean? Looks like a fancy
సార్,
term.
the reaction of the gun after the bullet is fired.
If bullet is fired in the forward direction, let's say towards east, what happens to the gun? bullet is fired towards east, what happens to the gun?
Recoil will be towards left, sir. I mean, west.
Towards west. Okay, gun will move towards west. Correct. So basically there's something called linear momentum conservation involved there. So same thing happens in rocket. Even in Diwali rocket, it's the same concept. When you ignite it, okay, it sends, due to the chemical reaction that happens inside and the energy that is generated, it pushes particles in the downward direction. Just a moment, let me download one image. So once it is lit up, basically what happens? It releases particles in this direction. Okay. So inside the rocket, on these particles, there will be force acting downwards. Inside the rocket itself, on the particles, the force will be downwards. Then on the remaining body of the rocket, the same force will act upwards. That is how it moves in that upward direction. And same is the concept in an actual rocket also, which is sent to space. Okay. So now there are space suits which have propulsion systems like this. They release gases, compressed gases will be there, or liquefied gases will be there. They release gas in one direction. It helps the astronaut move in the opposite direction. Now, I don't know how many of you have seen. Have any of you seen Chandrayaan landing?
Yes, sir.
In that, you might have heard of terms called boosters. So basically, what happens when the module is about to land on the moon, it is going to undergo crash landing. It will land with a high speed. But to control that speed, they use something called boosters. Now, that module is going in the downward direction. So if you switch on that booster in the downward direction, it will give an upthrust to the module, so that it can prevent it from going down so fast. Just a moment, I'm not able to find an appropriate image, but anyway, I hope you get the idea. Okay, why complicate things so much? You all must have played with balloons, no? So just a moment. Suppose a balloon is filled with air, okay, and without tying up the mouth of the balloon, you just release it. Vanilla, what happens? A balloon filled with air is simply released. What will happen?
It will start to move, sir.
The moment you released, the balloon would not have had any velocity effectively. Okay. When we say balloon, we are talking about the rubber sheet that is there and also the air that is there inside it. Okay. That system as a whole was not moving the moment you released. But after you release, what happens? Air molecules go one way and the remaining balloon goes the other way, right? So inside the balloon, due to the pressure that is there, the molecules, the air molecules, they experience a force. On the air molecules which are near the mouth of the balloon, the force will be outwards. And on the remaining system, the force will be inwards. So air goes one way, balloon goes the other. Same thing happens in rockets. Okay. Same thing happens in space boosters also. Okay. Like space module boosters. Same principle. They don't carry air. They carry some chemicals which can be converted into gases and can be propelled outwards in a particular direction as we want. Okay, anyway, so these are all applications of action reaction only. Rocket propulsion is application of action reaction. Balloon going to is also application of action reaction only. But still, what is the answer to my question? An object released in air, not air also, object released near the earth experiences weight. Where is the reaction to it? In fact, air resistance cannot be a reaction to it, because you know from everyday experience that air resistance cannot balance weight. So they are not equal and opposite. So definitely that is not the reaction that we should consider. So what is the reaction to an object's weight? Anyone? What was the last point I told? It is written here. If A exerts action on B, B exerts reaction on A. Now the force we are talking about is weight. Weight is a force exerted by what on what? Who or what is exerting this force of weight on the block? Pawan, what do you think?
Sir, block mass అనేది దాని weight ని కిందకి అంటే downwards పెడుతుంది సార్.
No. Can you repeat? Block mass?
సార్ అంటే గ్రావిటేషన్ ఫుల్ డౌన్వర్డ్ యాక్ట్ అవుతుంది సార్. దాని మాస్ కూడా డౌన్వర్డ్స్ యాక్ట్ అవుతుంది.
Mass act avadu. Mass is a scalar. It doesn't have a direction. Okay. Gravity acts downward. That part is correct. Mass is needed for gravity. Okay. And due to its mass, gravitational force acts on it in the downward direction. That is what we call as weight. దానికి అది ఎవరు ఎగ్జర్ట్ చేస్తున్నారు బ్లాక్ మీద? హూ ఇస్ ఎగ్జర్టింగ్ దట్ ఆన్ ద బ్లాక్?
Ground, sir.
Earth. Okay, don't say ground, you should say earth. Okay, so weight, this force is exerted by earth on the block. Correct. So call earth as A and block as B. A is exerting some action on B. Who should exert reaction on whom then?
Block should exert pressure on earth.
Pressure kaadu, reaction. Pressure is a physical quantity, completely different physical quantity. Okay, block should exert reaction on the earth, and that is correct. Block will be pulling earth in the upward direction. You have to visualize the system like this. Consider, just a moment. Never mind. Consider this as the earth. Assume this is the block. Of course, it won't even be that big compared to the size of the earth. So earth exerts a force on the block this way. Block will also exert a force on the earth this way. Okay, it is true. That force acts actually. But see, we see the block falling to the earth. Why doesn't the earth go and stick to the block? Why don't we see that? Why don't we observe that happening? Anyone?
సార్ మనం చూసే వ్యూ ప్రకారం ఎర్త్ స్టేషనరీ.
Okay, since we are on the earth, you are saying relative to us, the earth has to be stationary. Okay. Suppose you go to outer space. Okay, let's say you are an astronaut, you are somewhere here. Okay, astronaut should be in a space suit, whatever. And let's say someone throws a ball upwards. Will the astronaut observe the earth going towards the ball or a ball going towards the earth, or both will happen? You may not know what exactly the astronaut observes, but try to predict. What do you think will be seen by the astronaut?
Ball going
Sir,
towards
ball.
me, sir.
Kada. We see ball moving. I mean, the astronaut also will see ball moving. He won't see earth moving towards the ball. Okay, because if that is what is happening, there are so many people playing with balls all around. There are so many objects falling down to the earth. There are so many objects being thrown up. Okay, then the earth should move in many different directions randomly. That is not what happens, no? Why? If there is a reaction, if the block attracts the earth, why doesn't the earth move towards the block? The answer is in Newton's second law. Let's call this force as F. Think about it practically. What could be the force we are talking about is weight of a block, no? Tell me some example value of weight of a block. Anyone? How much shall we consider the weight of the block to be?
1 kg, sir.
1 kg mass అవుతుంది weight కాదు. What is the weight of a 1 kg mass?
1 kg
10
Newton.
newtons.
10 Newton. Okay, you have taken a small value. Let's take a large value also. Let's say 10 power 5 newtons. Okay, that is also not very large actually. It's practically like quite common. 10 power 5 Newton is a common force. Okay, so basically what I'm saying is, let's say the mass of the block is some 10 power 4 kg, 10,000 kg, then its weight becomes 10 power 5 newtons. Okay, you have to multiply mass with g, no? So 10 power 4 into 10 becomes 10 power 5. Let it be. That is the force exerted by the earth on the block. Then the block will also exert the same force on the earth. So the force on the earth will be 10 power 5 newtons. Okay, but if you want the earth to move, not if you want the earth to move, for the earth to move it should accelerate. Okay, force is 10 power 5 newton. That's the force exerted by that small block on earth. Compared to earth, it's small only. Then what is the acceleration of earth in that case? Force divided by, any idea what is the mass of earth? Mass of earth is around 6 into 10 to the power of 24 kg. Now 10 power 5 by 10 power 24 is 10 power minus 19. Okay, that's like 0.0019 zeros and then 1. Negligible. That is why we don't feel the earth accelerating. And also there is another factor. You are calculating acceleration based on force and mass. If you want to do this, you have to take the net force. This is non-negotiable. You can never consider only one force and find out the acceleration of a system. You should consider all forces acting on the system. Now tell me, practically, is that block the only object around the earth, or are there other objects surrounding earth also? There are definitely a lot of objects on the earth, no? So earth will be pulling all those objects. You can consider another block somewhere here being pulled this way, then that block will be pulling earth that way. Okay, some other object here being pulled by the earth this way, then that object will be pulling earth towards itself like this. That way there are infinite number of forces acting on earth in infinite different directions. The net force, the resultant of all these forces, is almost equal to 0. That's why earth as such doesn't feel any influence or doesn't feel any difference due to the objects surrounding it. Okay, so the objects surrounding the earth can't disturb the earth in any significant manner. Okay, but anyway, let's get back to the point that we were discussing. Weight of the block is the gravitational force exerted by earth on the block. Then the reaction to it, okay, reaction to it is the gravitational force exerted by block on earth. Even if there is a table, okay, let's bring the table back into the picture. Even if there is a table, weight is the force exerted by the earth only, no, not by the table. Weight is created by earth. Okay, reaction will be on earth only. The normal force is not the reaction to weight of the block. Is this point clear to all of you? Yes or no?
Yes, sir.
Right. Okay. So weight is the force exerted by earth on the block. Then the reaction will be exerted by block on the earth, and weight by nature is a gravitational force, right? If you call this as the action, if action is a gravitational force, reaction also will be gravitational itself. This is another property of action reaction forces. Action and reaction are always, there is no exception to this, of the same nature. So if action is gravitational force, reaction is gravitational force. If action is an electromagnetic force, reaction will be an electromagnetic force. It's like that. Okay. Tell me some other forces that act on the block.
Friction, sir.
Why will friction simply act? In which direction do you think friction will act?
Sir, if the block moves, it will act.
It is not moving. It is simply kept there. In this situation, tell me what forces act.
Normal force.
Normal force. Okay. What exerts normal force on the block? And in which direction? Pawan, you tell me what exerts normal force on the block and in which direction? Table, correct. And normal, as the word suggests, it is perpendicular to the surface of contact. We had discussed this. So it should be this way. This is the normal force by table on block. Okay, it's a force. It should have a reaction. One of you tell me what is the reaction force to this?
Sir, the block exerts normal force on the table.
Correct. The block presses the table downwards. That is the reaction to it. Correct. So if block exerts if table exerts normal on block, block will also exert normal force on table. Those are the action reaction. So normal force is not a reaction to weight. Right? Normal force may depend on weight. How much normal force the block exerts on table or table exerts on block, it may depend on weight, but it's not the reaction force to it. The reaction force to weight is the gravitational pull on the earth by the block. Gravity. Normal. Okay. Normal by table on block, normal by block on table. They are an action reaction pair. Okay. That is how action and reaction work always. So remember these 3 points. Third law states every action has an equal and opposite reaction. When we say action reaction, we are referring to forces. Okay. Next point. If an object A exerts a force on B and you call that as the action, then the object B exerts the reaction on A, not on some other object. Right? That will be the reaction. And third point, whatever is the nature of the action force, same will be the nature of the reaction force. There's one more point also. Action and reaction. See, we call them action and reaction, but it kind of gives us a wrong idea. In what way? Reaction, the word itself suggests that it's the response to something else. Okay, it's the response to the action. So it makes us feel that this comes first and this comes next. But it's not like that. They are just named action and reaction, but you can never tell which came first because they happen simultaneously. Action and reaction happen, or I should say act. They are forces, no? They act simultaneously. It's not like A exerts a force on B and B will exert force on A some other time. No, at that same time it will be exerting. Okay. So which force you call as action is your choice. Exerted by A on B you can call as action and the opposite you can call as reaction. Or at the same time, the force exerted by B on A can be called as action and the opposite can be called as reaction. Okay. So don't get misled by the term action and reaction. and think that one happens first and the other happens next. No, they happen simultaneously. As table exerts normal force on the block will exert normal force on the table. Okay, as Earth exerts weight on the block will exert gravitational force on the Earth. Same time they will happen. Okay, so next class, which will be tomorrow itself. Today's what, Thursday, no? Yeah. So next class tomorrow we'll see applications of Newton's second law, but we'll be considering first law and third law also. Second law has a formula. Okay, Fnet equal to ma, or Fs equal to Fnet equal to dp by dt. So problem solving will be based on that, but you have to consider the other laws also while answering questions. Okay, so all those things will apply from next class. Okay, if you have any questions, you can ask.